Good afternoon, everyone. My name is Marc Jones, and I'm the VP of Product Innovation at Softlayer Technologies. I'd like to start off a little lighthearted. A lot of people ask me what I do for my job, and this is basically my description to them of what I do. I often say I've got the coolest job in the company, coolest job you can have. I get to play with all the shiny new toys and figure out what it is that we need to go do next, who we need to partner with, and who we need to work with. So most days, not every day, most days, this is me. So Softlayer, we've got 100,000 servers under management. We've got 24,000 customers, and we host about 23 million domains. We are a partner of RightScale. Our cloud is supported in the RightScale platform. We have 13 data centers worldwide, US, Amsterdam, and Singapore. And then we've got an additional 16 POPs to go along with that from a network standpoint, so we have an international network as well. So today we're going to talk a little bit about internet scale, just kind of a good all-around discussion about what internet scale means and how you can achieve internet scale from an application perspective. Just really good architecture, good design. Just starting off, internet scale, much like cloud, much like enterprise class, really is the buzzword bingo worthy. But one of the areas of distinction that we're really honing in on is enterprise class versus internet scale, and what that means and what the difference is and how it applies. Looking at this slide, enterprise apps versus internet scale apps. With enterprise, we have a very defined user base. You know who's in the enterprise. Overall, you have a pretty good idea of what the number of users are, when they're going to use it, how they're going to use their systems. Contrasting that to internet scale apps, you don't know who's going to use your app. You don't know when they're going to use your app. You don't know if it's going to go viral. And there's really not a good way to capacity plan for that. Predictable. Enterprise workloads, usually pretty predictable. You know a lot of times when the workloads are going to start, whether it's a batch job, whether it's when people come in to work, when they leave work, whatever that might be. And again, internet scale apps, relatively chaotic at times. You don't know when they're going to hit. You don't know how many you're going to hit. And then from a cost perspective, enterprise apps really are, unfortunately, I think in some degree, characterized as a cost center within the enterprise. So it's really about getting the maximum out of the assets that you can from an IT perspective. And then contrasting that with internet scale apps, that really is the product itself. Obviously, you may have software sitting on top of it. You have a lot of other IP. But at the end of the day, the power that drives your internet scale apps is really about generating revenue. And so it's a different contrast on that. So from a Softlayer perspective, when we look at cloud computing, and again, we're not trying to put another definition out there, but from our standpoint, we really look at it as an operations model. We don't consider cloud to be a specific product. We don't consider it to even be a marketing term or even a reference architecture. It's an operations model. It's how you deploy infrastructure. It's how you manage infrastructure. It's all the key tenets of cloud. Capacity on demand, self-service provisioning, API, consumptive billing. That in and of itself is cloud. But that doesn't necessarily mean that it's a specific product or that it's even specifically virtualization. So we start breaking out internet scale. All the key tenets of cloud really apply to internet scale. On-demand, elastic resources, with elastic being both up and down. Scale in terms of resource availability. And predictable performance. And then remembering that scale does not always mean faster performance. Throwing additional workloads, throwing additional compute does not mean your app's going to run faster, it's going to run better. And we'll talk a little bit more about that a little bit further in. So a couple of examples, I'm sure all of you know the ones I'll throw up. Tumblr, 51 million blogs, 57 million daily posts, and 21 billion blog posts. And this is stats from a couple months ago. Properties like Tumblr truly are internet scale. They don't know, they have a product that millions and millions of customers use, and they don't know, they can't plan for when their customers are going to go viral. And so, great example of that. And then OMGPOP. So OMGPOP is the company behind Draw Something. So they've been around for years, right? They've had a lot of games that they've released on Flash and on mobile devices. Overall, successful company, but not really hugely successful. They release one game that has everything that for whatever reason, resonates with all the users out there, and literally overnight sensation. So 50 million downloads, users generating 30 hours of drawings a second. And then $200 million, obviously the price tag that Zynga paid for OMGPOP after one game took them to the top. So from a Softlayer perspective, Tumblr and OMGPOP are both on the Softlayer platform. So we get to see firsthand how our customers are building out infrastructures, how they're scaling infrastructures, and then how we can better tailor our infrastructure to meet not only their needs at the high end, but apply that to everybody, whether it's a small startup, an SMB, or an enterprise. Then if we shift to, from a retail perspective, internet scale, seasonality obviously being a key. I know Michael even addressed that this morning, talking about some of the seasonality that they see in their compute usage. Handling spikes in compute needs with a seasonality perspective, whether it's, depending on what type of retailer you are, you know that you're going to have spikes in certain times of the year. So being able to have a baseline of compute and being able to burst and extend above that is critical from an internet scale perspective. And then, does an SMB really need internet scale? And the answer is yes on that. We've got a number of customers that are, from a usage perspective, relatively small. They may not ever be big from a day-to-day standpoint, but when they do hit it big, whether it's a Twitter promotion, Facebook, something goes viral, if you're not built to be able to support that, then when that happens, when this huge spike occurs, you're not ready to handle it. And you've lost all that traffic, all those potential customers and all those eyeballs that could have been on your site. You can't handle it if you're down. So even from an SMB perspective, starting out, it's the beauty of internet scale. You don't have to start out with huge infrastructures, right? It's about scale. Start small and grow. So when we talk about built for internet scale, just kind of a sum up of the points, right? Unpredictable traffic patterns, unconstrained user base, global deployments, right? That's becoming really the new norm. It's not just about deploying in a data center, and even potentially not even with a cloud provider, right? Multiple cloud providers, multiple geographies is incredibly important. It's about reaching your end users. It's about their performance, from a user experience standpoint. Network sensitive, the network is really becoming key as it relates to cloud. I think that for a long time the network was an undervalued component of cloud, and now is really getting a lot of focus, from a latency perspective, but also from a reach perspective, and we'll talk a little bit more about that. And then leading edge technology stack. The companies I talk with Tumblr and OMGPOP, a lot of the internet scale leading edge companies are all embracing leading edge technologies, some degrees bleeding edge technologies to achieve that. So digging in a little bit more to internet scale, from our standpoint, it really starts with choice. And we firmly believe that applications really dictate your infrastructure, not the other way around. So as you really look to move applications to the cloud, as you look to really architect, design, and implement applications that will achieve internet scale, you need to start with your requirements in mind. So it's not just about what can I go do at a service provider, or what even can I do in my own data centers. It's about what do I need to do from an application perspective, what choices do I need to make sure that I can scale these applications. Workload characteristics, performance targets, control requirements, there's a lot that goes into that from a choice perspective. So starting off, ideally, new application, new startup, new company, kicking it off with some design and architecture. Obviously, there's a lot of legacy applications and legacy code that's in existence. The same process really applies to that from a refactoring perspective, when you're going back in and you're able to rework code. Applying these principles to that from an iterative fashion can also get you there. So really starting off, why is scalability so hard? And it can't be an afterthought. You need to think about it ahead of time. Obviously, once it's out there, if you hit scale problems, if you hit a wall, it can still be achieved. But obviously, we're going to pay a little bit of a penalty, whether it's from a user experience standpoint, loss of revenue, loss of eyeballs. So really thinking about it up front is critical. And is achieving good scalability possible? It absolutely is. But it takes a planning, thought, and really the architecture and design is key to that. And I mentioned it earlier a little bit. Simply throwing additional CPU cycles is not going to guarantee that your application is going to scale. Now, it will scale it, and it might scale it and it might work, but you're going to get ideal scale when you're able to build out a design, a reference implementation that can take advantage of the underlying platform, either from an infrastructure perspective at the physical layer, or even from an application perspective, like with RightScale. Leveraging server templates properly, designing that can really help you achieve this. This is probably one of the big things that I preach over and over and over again to my team, and that's simplicity over complexity. Think simple. It just, obviously has the word simple in it. It sounds like it's a very easy thing to do. Simple is actually very hard to do, especially when we're talking about software design, software architecture. Eliminating multi-step processes. There's a lot of change in the last few years about how you design applications, how you design architectures. Really reducing each step of a process to its atoms. Isolation, and then being able to orchestrate all of these processes, all of these steps, gives you a little bit more granular, fine-grained control over what you can do and how you can scale all of the independent processes and even, we say atoms, but all the individual components of your infrastructure. Moving away from monolithic code bases, moving away from large deployments, and really becoming isolated services, orchestrated services that are easy to iterate on and easy to deploy. And this is a quote that one of my lead architects came up with. A system can be so simple that there are obviously no bugs, or it can be so complex that there are no obvious bugs. He sent that to me in an email. I was like, well, that's very profound. But it's very true. And so this is really, again, very hard to do, but with that kind of context, it really has helped us, helped my team try to get to that point. So continuing on, tools. Choose tools that can grow. Obviously, tools can be all-encompassing and can be very wide. But starting from language of choice. Obviously, there's a lot of languages that we can choose today, but in a lot of them, most of them are really starting to meet the needs of internet scale architectures. Some of the new trends with DevOps is really, in my mind, very key to helping this happen. Automated deployments, automated configurations, and then automated management and monitoring, helping you get it out faster, helping you configure it faster, and doing it without a lot of hoops. Push button, turnkey solutions that can help you achieve, whether it's deployments, code updates, restarts, anything like that is really key to this. And then something that we talk about from cloud, but is not talked about a lot, but very important. Choose tools that can help you shrink. So it's not just about internet scale and expansion. Obviously, we all want that. We want our businesses to continue to grow and never have to worry about scaling down. But the reality is that we're not always going to need to grow our environments. So being able to very easily shrink deployments down to meet the needs of your compute, don't pay for anything more than you need to. So it's critical. And then obviously just leveraging the best that meets your requirements. Common theme throughout is it's really about what you need to meet the needs of your applications and being able to select that. From our standpoint, overall, from a tool standpoint, a management standpoint, it's one of the things that we love about RightScale, right? It gives you all of this capability in a single dashboard, a single pane of glass, and allows you to fully scale out, scale down, manage, deploy everything. And so this really can be summed up with just the RightScale logo right across the middle, and that says it all. From a design perspective, and there's a lot that you could do from an architecture design pattern perspective, but two of the key things that we've really embraced at Softlayer for our internal design, as well as products and services that we're currently developing, stateless and async. So as we start taking larger applications and really developing it into discrete services that are orchestrated, step one is not having state. So obviously there's going to be applications that have to have state, but any time that you can, don't have state. State is expensive. State for HA purposes, ideally sessions would need to be shared, and sharing sessions in HA obviously adds overhead from a memory footprint perspective as well as just from a network chatter perspective. Again, you're going to have state at times, but where you can, don't have state. And then asynchronous. Anytime that you can have non-blocking calls it really frees up resources on the servers to be able to serve more requests. And so anytime that you can move to an asynchronous request, which usually means it's a process that a client does not have to have a response right away. So these two things together really are pretty powerful, and it adds a lot of scale characteristics to your applications that you wouldn't otherwise get to. Side note on async, asynchronous really makes testing a little bit harder, especially when you're using, there's really great asynchronous frameworks in a lot of the languages today. We've got a project right now that we're working on. It's going to be a public-facing, internet-based service that we've written in Ruby. And we leverage Event Machine in Ruby, which utilizes what's called a reactor design pattern. What's great about that is from a client perspective, it feels like it's synchronous. I'm doing a request and I'm getting a callback. But on the server side, it's basically getting that request, effectively blocking it, but able to service more and more and more. And it has like a loop that goes around. Services request, comes back, and then gives a response back. From a testing perspective, though, it was driving my developers crazy because if you've got a bug in that, it's not a very easy synchronous, send a request, get a response back, especially on the server side. So having unit tests and test coverage as early as possible in your development, and that really applies to whether it's asynchronous or not, is key. In this same project, we really, probably for one of the first times, we really focused on test coverage from the very beginning. And with that, we were able to uncover bugs that, so from a test coverage perspective, you start out with pretty basic test coverages, and then you continue to add to that. So as we got to the add to that part of it, we were able to discover bugs that we hadn't thought about, and that would have been a major pain to have found in production had we not done that. So test early, test often, it will definitely save. Bottlenecks. Bottlenecks still exist and are very real in every infrastructure, every provider, every piece of hardware that you use. There's ultimately potentially a bottleneck. And so it's really just about understanding what they are and what they might be and doing everything that you can from a design and architecture perspective to work around that, to eliminate the choke points. The two biggest ones that we see and that our customers see is I/O, and it's I/O that's related to network and to storage. So from a network perspective, I'd say it's a little bit easier because now obviously we can go up to 10 gig NICs on the host, so we can push a lot more data through the host, and then we can scale that out. Storage is a little bit trickier, particularly when it's shared storage. So if you're using a network attached storage or a storage attached network, and that's having to flow across the network, and it's a multi-tenant device, I/O is a little bit more challenging because you're obviously competing with other people on that box. So resource isolation on the boxes makes it a little bit tougher. So again, it's really just about knowing what those contention points might be. Do I need to have SAN storage, or can I do local storage? If I can do local storage, I can do a little bit more to control the I/O and potentially even architect it differently, and we can talk a little bit about that just a little bit. And then kind of back to the whole testing thing, but really trying to find flaws as early as possible, whether it's from a design perspective or even an implementation, and try to find them on purpose and not once it's in production. And then being a hosting provider, this is probably the last thing I want to have up here, but expect failure. Everything fails from time to time. Hardware fails, whether it's a hard drive, network cards, network elements, anything. Peering with your transit partners from a network perspective, there's going to be hiccups along the way. So from an architecture and design perspective in your applications, it's really important to try to figure out when that could occur, where that might occur, and how I can architect around that. And that may be geo-redundancy. It may be within a provider that you do multiple zones, but really taking into account what might fail and trying to plan for that ahead of time as opposed to reacting to it once it happens. So digging into kind of the infrastructure layer now, some of the key components. Connectivity, as I mentioned, it's a little bit easier these days to control the network. We can do 10 gig on that. Obviously from an IP perspective, V4s are drying up. IPv6 is really starting to roll out now. So being able to have that as an option to help your infrastructure. And then having multiple networks can also help. So being able to have servers, whether they're cloud servers or dedicated servers, that have multiple networks that you can talk on. So you can isolate traffic on a private network, not have to worry about flowing out to the internet. Anything that flows across a private network typically has a little bit better latency. It's going to have a little bit better quality of service than when it flows out over the internet, over the public internet. So having the option to be able to flow traffic for infrastructures across a private network and then egressing or ingressing from the internet over a public interface gives you a little bit more control over your scale out of your architecture. Network reach. Not only having really good transit and peering in your data center with your provider, but also having coverage, and in today's age, having international coverage. So I mentioned earlier, we've got 16 points of presence around the world, and the goal for us is that not necessarily for Softlayer, but for our customers, being able to have their customers get onto our network faster so that we can control that network experience. We can have better latency and better quality of service. So having the POPs worldwide really helps the end customers get onto our network faster for our customers that have products and services running in any of our data centers around the world. And then distributed. We talked about it a little bit ago, but having a choice of where you deploy your applications, international, domestic, but today's day and age, your user base is going to be worldwide. You don't know where they're going to be. You don't know where they're going to come from. So having the options to deploy worldwide across providers, within a provider, having this choice, though, really helps you scale to your end users from a performance perspective. Storage. Another key, as I mentioned, this is really one of the killer from an I/O perspective on scale. And so from a Softlayer perspective, we really look at compute as compute. And what I mean by that is we don't just say we're a cloud provider and we have virtualized cloud instances, but we also do dedicated servers. And so before we had hybrid, meaning on and off premise, private clouds, hybrid used to mean dedicated servers and cloud servers. But being able to have a degree of control over your local storage or being able to know what's in there and ideally configure your local storage really gives you more control on scaling out your I/O, your IOPS from a storage perspective with each of your server nodes. And having options. So from traditional spinning disk to SSDs, building that out and configuring it to meet the needs of your workloads. If you have a memory-intensive application that doesn't need disk I/O, then you can go with older SATA drives that are just spinning disk. If you have very I/O-intensive applications like a database, being able to have an SSD option is really key to helping you scale that. And then from a network storage perspective, the network storage devices, the vendors are really getting better about QoS across the network, QoS for multi-tenant. And then we have a new wave of vendors that are really coming out now that are producing SSD-based SAN solutions. And it's good because it gives you additional IOPS from a SAN perspective, really maybe from a provider perspective and even from a customer's perspective. But what we're seeing is not just a shift to SSDs from a storage perspective, but building effectively new operating systems from a storage for storage units around SSDs. And what that's doing is giving fine-grained granular control of the storage devices that we didn't have before with spinning disk. One of the ones that we're looking at and we're talking to is building out an entire SSD-based solution, SAN, and you're able to have QoS on individual LUNs. So basically, if you have a volume, a storage volume, you can actually go in there and say, this is how many IOPS that volume gets, and it can burst this amount. And by doing that, you've isolated those IOPS, and you're not going to impact any of the neighbors if it's a shared multi-tenant device. So that was really designed and built for the service provider market to help end users have a better experience. And then OpenStack. From a storage perspective, we have object storage, S3, Swift, from an OpenStack perspective, and Cloud Files at Rackspace is really becoming a key component of scale-out architectures. Being able to leverage an API-based storage solution that you can use for, I hate to say non-critical data, but data doesn't have to be high performant, but does need to be fault tolerant. It needs to be there. You can't lose it. and you need to have access to it, and you have a lot of it. This is a great solution for that. So we talk about scale out. Inventory is key. Obviously, you can't deploy what doesn't exist. The beauty of cloud right now is that all the providers have really done a great job of making cloud feel infinite. And from an end user perspective, it really is. The providers have done a great job of being out ahead of the curve and having sufficient capacity so that end users just keep growing. And so we do the same thing from a dedicated server perspective. So we always have inventory ahead, and customers have the option to build out based on their needs. And so from a server perspective, everything in our world starts with a dedicated server. We have an API layer, and then using those dedicated servers, you have the option to leave it a dedicated server, bare metal OS. You put OS of your choice on that server, configure it how you want. And using a dedicated server, you get every ounce of compute of IOPS out of that server. There's no hypervisor tax, there's no overhead associated with that. You have the option of setting up cloud instances on that box. So from a Softlayer perspective, much like other providers, everything for us is a server. And if we need additional public cloud infrastructure, then we have an automation platform. We configure it for public cloud servers. Customers can also get dedicated servers, and you can build out your own virtual servers and private clouds. So you have complete flexibility when you start with this notion of the center of the universe really is the dedicated server. Common network I mentioned earlier, and then this really yields hybrid architectures where you can pick and choose what you need. You don't have to have one solution. One solution doesn't fit all. You can mix and match those solutions. You can have dedicated servers for your databases, and you can have your webheads be cloud instances, and it really gives you the best of both worlds. From a scale-up perspective, cloud, a lot of times we talk about scale-up or scale-out and scale-down. Scale-up is key for really, again, squeezing these boxes and get everything out of it that you need to get. So if you have database servers, you have Hadoop clusters, and you want to have significant performance and throughput on every server, then scale-up means that you've maxed out the CPUs that you can have in it, you've maxed out the memory you can have in it, and you've built out pretty substantial local storage. It's about really within a chassis, how much can I do in that for a given architecture. Scale out obviously is the classic cloud example. As you need more compute, you simply add it, scales it out. When you don't need it, you pull it back down. And that's definitely, from our standpoint, we see this a lot with our customers. One thing that we introduced earlier this year is this notion of flex image. Again, as I said, dedicated servers are really the center of the universe for us. And one of the things we love about cloud, and one of the reasons cloud is so successful, is because of the capabilities of imaging. Images from a hypervisor perspective abstract out the underlying hardware. It allows you to take that snapshot, create your gold master for your webhead, your app tier, whatever that is, and then be able to really quickly redeploy that. That image management really only applies to virtualized servers. So if you want to move over to dedicated servers, then you've got to go through an ordering process, you've got to lay down an operating system, and then you still have to go through the process of configuring that server. So we've built out a system that allows you to take effectively snapshots of your dedicated server, create an image from that dedicated server, and it actually goes into your image library. You can use that same technology to do the same thing from a cloud server, and then you can interchange those. So you can actually take an image of a dedicated server, and then you can deploy that to, say, 10 webheads that are cloud instances. Or you can take a snapshot of a webhead and deploy it back to a dedicated server. And so what that does is it gives you ultimate flexibility. If you start out on cloud and you realize you need more performance, then you can take that image and deploy it to dedicated servers, and vice versa. You're going to attack the world. You're going to be huge. I'm going to start off on a big dedicated server. They didn't come. I'm going to shrink it back down. I can deploy that same image to a cloud instance. And then time. This is one thing that cloud has definitely changed from a customer expectation standpoint and from a service provider delivery standpoint. Provisioning speed, API feature set. Cloud needs to be delivered in minutes, if not faster sometimes. And even from a dedicated server perspective, you're seeing provisioning times drastically reduce. You know, it used to be days, it used to be weeks to get dedicated servers. You know, now we can deliver a dedicated server in 2 hours or less. And we continue to move on that. And we're not the only provider that can do that. But having that power of choice and getting compute so fast has radically changed the game. And then ultimately control. Everybody has this, everybody needs to have this. Mobile clients to manage your infrastructure across all, portal, and then APIs. So better living through programming. Being able to have programmatic access to everything that you could possibly do in your infrastructure is key. It's how you scale. It's how you scale rapidly. It's how it's how we're able to integrate with RightScale and make that happen so seamlessly. So I'm going to talk a few minutes about private clouds and how private clouds really take the best of enterprise class and the best of internet scale and really kind of put the two together. We've introduced, yesterday we announced that we're launching a private cloud offering. And private cloud is a cloud that is built on dedicated servers in Softlayer, but it's dedicated to you as a customer. And it leverages Cloud Platform from Citrix, which is based on Cloud Stack. So if you need to have a turnkey solution for a private cloud where you take all multi-tenancy out of it and you're just focused on, I want the capabilities of cloud, but I want to have full control over that environment. This is a solution that we've built for that. So we went with Cloud Platform, very mature product, been in the marketplace for years, originally cloud.com, acquired by Citrix. It is very mature, and they have been for a number of years now a leader in cloud management and orchestration. And then from our standpoint, RightScale compatible with MyCloud, so we were able to actually deploy this infrastructure and be able to go into a RightScale dashboard, put in your credentials from Cloud Stack, and you're able to manage a private cloud deployment. And it meets the needs of scale, flexible network architecture, and then it's also an open source platform with recent announcements from Citrix on contributing to Apache. So with private cloud, you're able to deploy zones. Zones are isolation for redundancy and typically within a data center. And you're able to deploy zones within data centers or in multiple data centers. And then with the management server that gets deployed as part of it, you manage your entire infrastructure across all zones. And then within a zone, you're able to build out clusters. And within those clusters, you have your guest hosts. And the guest hosts are actually where your VMs are going to run. And the management server allows you to manage all of this infrastructure. Clusters are really, in a cloud stack world, defined by storage. So with our initial release, we're going local storage on the guest host, and then ultimately we'll go with the SAN-based solution as well as an option. So you'd be able to have multiple nodes in a cluster that have shared storage in the back end that would give you like VM motion capabilities. So today, with us, with any provider, you can go out and do your own cloud stack installation. It's a great product. You go out, you order your servers, you do all your installation. So what we did to try to make it easier is make it effectively a turnkey solution. So working with Citrix, we have our management node specs. And so it's really, from a hardware perspective, it's something that customers don't even have to worry about. It's part of a deployment. And then from a host node perspective, this is really where we feel the power is you get to configure this host node to meet the needs of your compute. So it's been a common theme throughout. I've been saying, really try to build and define architectures that meet your needs. And so with the host node options, you're able to configure your procs, your storage, and your network for all guest hosts within a deployment. So the big picture from a private cloud perspective, what we see is having the power to have private clouds, whether it's for dev test environments or even your production environments, that really is that baseline for you. You want to control that experience. But being able to leverage, whether it's additional cloud services for burst augment or burst to power more I/O intensive applications, such as Hadoop clusters or databases. You have full capabilities to control that. From a Softlayer perspective, you're ordering it and you're doing the hardware management in the portal, using the Cloud Stack interface to do all the management or leveraging the API. And then from a RightScale perspective, you're able to fully manage your deployments. And that is it.